Hello, I'm Christina, head of product for GameLift, and I'm joined here today with the Star Wars Hunters team. Really excited to have been working with them over the past year or two on this, and I'm really excited for you to hear about it from themselves. So without further ado.
Thank you, Christina, and welcome everybody to AWS reInvent. Okay, I'll jump straight in. So imagine it's the day that your multiplayer game is coming out. You've done a good job, the game looks great, it plays well, and it's a day of celebration. Everybody's in the kitchen, they're having champagne, they're having cake, and there's balloons everywhere. No stress. Unless you've got anything to do with server or infrastructure, in which case today's maybe not that stress-free. Imagine you're a player. You've been waiting for the game to come out, you download it onto your phone, you choose your character, you choose your skin, and you hit play. And you wait, and you wait, and you wait a bit longer, and you get an error message. Matchmaking failed. Failed to find server. This would be pretty horrendous on launch day. If I'm the player, maybe I'm going to delete the game, write something not so great on social media, and never play again. When you're on the server team, you feel like the responsibility of the game, of launching the game successfully, has shifted onto your shoulders. Today, I'm going to be talking about how we use Amazon GameLift to alleviate these launch day fears. I'll be talking about multiplayer game requirements and GameLift resources. Chris is going to be talking about our implementation journey. And Steve from AWS will talk about some recommendations. So who are we? Chris and myself are from Zynga, and we're from Natural Motion within Zynga, who have produced CSR2 and Dawn of Titans. Today, we'll be talking about Star Wars Hunters. Hunters was a first for us, first console game, real-time, cross-platform. So there were many challenges that came with that. But before we jump into it, I'll show you a little trailer of our previous season. Some people like stormtroopers, some people like lightsabers. If you like natives from the planet Endor, then this one might be for you.
Yep.
So there you have it, Star Wars Hunters. In case it wasn't obvious from the teaser trailer, it's a 4v4 arena-based combat game. It's a character class-based game, and it's all about playing other people. It's multiplayer, and that's what we're going to talk about. What are the needs of a multiplayer game? So from a server perspective, infrastructure perspective, what we care about, what a player cares about, is that their games are fair. They're playing against players that are not too much better than them and not too much worse than them. You want to be engaged. We want to be playing with players in the same region so that we all have a similarly low latency. And if I'm queuing up for a game, I don't want that to take too long. How does this get implemented? Well, we have a number of players presenting themselves with various attributes. Some of these are implicit, some are explicit. And we have a matchmaker. And the matchmaker isn't just going to say, let's treat these players in a first-come, first-served basis. It's going to say, let's look at the pool of players and understand, within a reasonable amount of time, like what are the players that are kind of matched in skill and they want to play the same kind of game. So once we have those players, we have 8 players in the case of Hunters, we'll throw those 8 players into a server placement algorithm. The server placement is going to say, okay, what game servers do we have in the world and what game server is free, and let's move those players onto that server. So next up, the server. It's a fully authoritative server. So this server has to simulate everything which is happening on every client. If I run around the corner and someone shoots me, but I duck in time, I want that to be reflected on my machine as well as theirs, regardless of the speed of my device or my network connection. Something I didn't mention before about Hunters, we're multi-platform. So we're on iOS, Android, Nintendo Switch, and actually coming early next year, we're going to be releasing on PC in early access. So download Hunters on PC if you want next year. So back to these servers. So we compile the same game code onto a Linux-based server as well. This game code is pretty heavy because it's doing all this simulation work. And we don't have many players per server. We have a very low play-to-server ratio. If you're running a web server, you can have thousands of users, and they don't normally need to be on the same server as other people they might be talking to. A game server, we have to have the same 8 players on this one server. So we have a lot of servers, and the other need, because we need to be low latency for all those players, is we need to have a geographic distribution of these servers around the world. So these were our requirements, and as any engineering group does, we said, OK, let's build out a prototype. What was in it? We had our platform service. Chris will talk about this more later. Platform is what the game is going to be talking to prior to a match, things like the shop or choosing what maps you want to play. We have the matchmaking server, which we just spoke about. And we have this server orchestrator. This orchestrates an ASG. These are your instances that are spinning up and down that actually contain your Linux servers. Now, was this going to work for production? It could have. We could have built it out. Did we want to have to rely on maintaining these matchmaking and orchestrating servers for years and knowing that they were also the single point of failure for the game? Maybe not so much. We'd rather spend our engineering efforts on the game or internal tooling, which we'll talk about later. So we decided to retire this solution once we kind of understood what was needed from it. And we choose GameLift. No surprise, because I'm here today. Main reasons for choosing GameLift: global presence. We get to take advantage of all these servers around the world that Amazon has. Cost optimization. It helps us lean on things like Spot Fleet, which are much cheaper without all that much effort. And the killer feature for us was matchmaking. Out of the box, data-driven matchmaking, easy for anyone outside engineering to change how we're going to decide how players land in a game. So we're using GameLift, and what I'd like to do is talk a bit about how we used GameLift. Could I get a show of hands of people in the audience that have used GameLift before? Couple? So what I'll do then is I'm going to talk about the different resources that are available to you within GameLift and how these join together so that we can play a multiplayer game. OK, so first up, we have this flex match rule set. So this is a JSON file that contains your rule definitions. How long do I want to wait for players to join the match? How close their skill levels need to be? Things like that. Next up, the config. This config is really just the glue between this rule set and the downstream servers that we're going to be talking about. On hunters, some specifics. We wanted to make sure we could replace these rules quickly in production. And from the development perspective, since anyone can be changing these files, not just engineers, we want to make sure that they're correct in our source code repository. So we have a post-submit rule validation check that validates, is it valid JSON, which is easy to do, but it also sends it up to a GameLift endpoint to say, is this a valid rule file or not? If not, let's ping the user. Next up, we have this game build object. For those of you who've had to maintain server images before using something like Packer, you'll know that you have to kind of fill the image before you actually snapshot it. These are the files that are going to go into that snapshot. Binaries, scripts, non-game binaries as well. What does it look like for hunters? So we start off with this Linux server binary that we've compiled. This comes out of our Jenkins build farm. We add on some additional agents, which we'll talk about in a little bit. And we have this parameterized install file. So depending on whether we're going to be deploying to staging or to dev, we have this file that will parameterize with different service endpoints. We wrap it all up, we archive it, and we throw it off to S3. We put it into an S3 bucket. Once it's in that bucket, we'll register it with GameLift, and that's the beginning of our GameLift build, or our server journey, you could say. So now we need to run the actual games. And we do this on a GameLift instance. So this instance is going to contain one or more invocations of your game server. We can run between 1 and 50 servers right now. And how many servers you run is really going to depend on how much CPU your game is going to utilize. You don't want to just have one server on your instance because this is going to cost a lot of money. If you pack too many on, you could risk one game server kind of spiking in CPU, and that's going to cause all the other game servers to feel it. And if you're playing a real-time multiplayer game, if any of you do that, you definitely know when your server is throttled on CPU because you're just dropping frames everywhere, and it's not good. what do our Hunters instances look like? So we run between 4 and 8 game servers per instance, and this is what our outside players are connecting to. So this is a public instance. And we also back it up with a few auxiliary services to help out our internal processes. So what do? GameLift does give us metrics out of the box. It gives us CloudWatch metrics, but we also have our own agent running on the machine that pulls out some other information that we might need for later on. This gets sent to Prometheus. We also have a custom logging agent. Again, out of the box, GameLift is pretty good. At the end of every game session, you get a text file which contains a log for that game that was just played. However, because we were running at such scale, we wanted to make sure we had some kind of log aggregation service, and that's what we're doing here. We send everything from the instance into OpenSearch. Finally, in dev, you're going to have crashes. In prod, hopefully you don't have too many crashes, but you might. So we have a custom reporting agent, which we've written in Golang, that sits on the machine, and when a core dump is detected, it'll send that off to an S3 bucket, and it will send it to a crash aggregation service as well. One thing we had to make sure of was that this had some throttling logic built into it. There'd be nothing worse than a game server crashing at launch and having 1,000 game servers crash at launch and send all their core dumps, which are like 1 gig, into S3. Your bill would be pretty high. So that was one instance, but hopefully you have enough players playing your game that you need more than one instance worth of servers. So this is where our fleet comes in. If anyone's used EC2 before, you might be familiar with auto-scaling groups. A fleet is kind of like an auto-scaling group. You have these numbers, minimum, maximum, and desired number of nodes. And depending on the play demand, this will increase or decrease over time. We have parameters that we set on the fleet. We can talk about what is our scaling rule, like how much headroom do we want, like when do we want to scale. We have instance pricing models, on demand or spot, and we also have instance sizes, same as EC2. My favorite feature, though, of GameLift fleets is the fact that it is multi-region. There's nothing worse than having to kind of track which region in the world we're running resources in. With GameLift, we spin up a fleet in a home region, so in this case, US East 1, and we pretty much can like tick some checkboxes and say, okay, now my game is available on the other side of the world within about half an hour. Running these fleets is actually somewhat complex, and I know questions do come in, like how do I determine how many instances I should be running where? In the case of Hunters, during development, we could say, okay, let's just run a single fleet. This could have as many instances as we want in it, but it's still restricted in some ways. So in this example, we have a C5 large on-demand fleet. But we might talk to finance, and they might say, hey, can you optimize your costs a little bit because you're running a lot of servers? And we can say, yes, we can, and we can run Spot. A game like Hunters is an ideal candidate for a Spot instance because our game match lengths are short. And GameLift doesn't actually place, or GameLift is smart enough not to place us onto sessions that are going to be finishing soon. So we can use Spot. Another consideration is instance diversity. So let's say it's Cyber Monday, and there's some kind of retailer in the same Amazon region as you using up all of the C5 instances. By using different instances, like a C6I large here, we can ensure that, well, we can reduce the probability that we're going to request an instance and it's not going to be there for us. On Hunters, we end up running about 12 different fleets. Some of them are much older instances, some are new, to make sure that we do have instances available. So in terms of calculating those numbers, let's come up with a hypothetical scenario where we've said, okay, how many servers do we need in AP South 2? We talk to product, and they say, you're going to have 16,000 concurrent players in this region. So we have 16,000 concurrent players, and from before, we remember that we have 8 players per server in the ideal case. So that gives us 2,000 game servers. Let's say we're running 4 game servers per instance. So that's that packing problem we were talking about before. That gives us 500 instances. Now let's do a 50-50 split between C5 large and C6I large. And then finally, we'll have some percent that we allocate to on-demand and another percent we allocate to Spot. Depending on how conservative you are, you might say 100% on demand if you want to make sure that you're guaranteed these instances. We could say 90%, 100% spot if we don't mind the fact that we might not be able to scale up if there's no instances available. And over here, we do the same for the C6i large. So that's how we do a fleet calculation. And applying it to this matrix, we could say, OK, those are our numbers per AP South 2. And we would do something similar for every region that we have. Now, this process is somewhat laborious. So we've built tooling around it. We have these fleet sizing calculators. So we can say, OK, this is what we expect in these regions. And we can always also look back at historical usage that we capture to say, what was our season 1, season 2, season 3 launch looking like? And let's apply those limits to our next season launch when we're doing the scaling. The tooling also does some cost estimation. We can say, what's it going to cost if we are running 50%, 80%, 20% spot versus on demand? So that's all the maths for today. And I'll talk about a simple concept, which is a game session queue. So this game session queue, what's it going to do? It's going to aggregate all those fleets we spoke about. So we spoke about having that group of 8 players that we want to throw into a queue. Those 8 players will hit this game session queue. And depending on the latency, whether we're optimizing for cost or latency, depending on the policy, we'll decide which server to put players onto. And there you have it. Those are the resources that we use on Hunters for GameLift. We don't use every resource available. We're not using aliases, but what we have here does the job. You'll see that for a single build, we're not just using one of each type of resource. We have multiple fleets, as we discussed. And we might also have multiple rule sets. These rule sets represent different queues. So if you're playing Hunters, you'll have a casual queue. You'll have a ranked queue, which is more competitive. And you might also have we might have like a special event on, such as Hutball. So we're running all of these servers, and we're trying to understand what's going on. So what do we actually capture? As mentioned earlier, we want to, at the most atomic level, look at what's running on an instance. What is the CPU looking like? What are some of our other server metrics? This is going to drive that packing question that you have. How many game servers am I running on each instance? More holistically, we might look at things like matchmaking time, which Chris is going to talk about. We could look at fleet utilization as well. I care a lot about cost, and we might realize that our fleets are underutilized. We have too many empty instances spinning up. So we'll adjust that in a short term, or we might just adjust it for the launch of the next season. We also have inventory counts. So we have resources that are limited, not by cost necessarily, but we may have, I think out of the box, it's about 30 queues per account per region. So we need to keep track of these so that we can put in a request for more, or just to make sure that we're not using them unnecessarily. So we count our resources, like how many configs do we have, how many rule sets do we have, and we may also, through load testing, look at our transactions per second, because we want to know, again, on that launch day when we're being hit with many, many players, that we're not going to exceed any threshold to get throttled by AWS. So how are we capturing these metrics? We spoke about some of these usual suspects, Prometheus, CloudWatch. We use CloudTrail to look back in time to understand what events we were calling, and we've also written some custom scrapers that plug in for Prometheus. How do we view these? We have dashboards in Grafana and CloudWatch. Some of these are auto-generated per build, and we also send anything that doesn't look right to Alert Manager, so people get paged. OK, so that's the, I guess, looking from an engineering perspective in terms of like how we actually build our fleets up and how we use them. But how does the Natural Motion Studio actually say, hey, let's play some multiplayer games? There's many reasons why you might want to deploy a fleet or a deployment. You could be a developer testing a change. Maybe you're the maps team and you've got a new level and you need to test this in multiplayer mode. And of course, you might be launching into production or soft launch. We want people to be able to use, play multiplayer games, like private multiplayer games, but we don't want them to have to understand, like, what is a Linux server? what is Amazon GameLift, like what is the Amazon console. In fact, it'd be pretty dangerous letting everyone in the studio just log into the console. So we've built this tool called Fleet Deployer, and this sits between the studio and the GameLift API. And it's basically a website and an API that anyone can use. So there's all these resources which we just mentioned. There's quite a lot. And what Fleet Deployer does, it aggregates them into one little object. We call this object a deployment group. From the outside, if you're a user of Fleet Deployer, all you know is that you have a deployment. You don't know about those like 10 or 20 resources that are in there. But the deployment is kind of like an inventory of those resources. And we annotate it with some additional metadata. So there's some example metadata here, description, owner. More interestingly, we have some time-based metadata. So we could have a user that logs into Fleet Deployer, and they'll spin up a fleet. They'll say, OK, I just made build 123, spin up a fleet for build 123. Fleet Deployer will then monitor GameLift, and it will monitor that fleet to understand when it's ready. The reason we do this is because we create these resources. Most of them are available instantaneously. However, things like fleets can take about 30 or 40 minutes to spin up. So we wait for it to spin up, and then we notify the user on Slack, in our case, and we also notify our platform service to say, hey, build 123 is now ready to accept players for a multiplayer game. We can do a scheduled scale-up. This is not so necessary for production, but internally, if we have a playtest, let's say at 10:30 on Monday, we have a playtest where we're going to go from 0 players to 200 players on a test fleet. We scale up, which happens maybe 5 minutes prior to that call, so that images or instances are ready to go. We scale down, and we also have scheduled shutdowns. We might want to say we're doing a demo at a conference, and we want this fleet to shut down at the end of the week. Or we might say, and this is the really handy one, by default, we could say, OK, a fleet should shut down after 24 hours if no one's played on it. And this has really helped us because I think at the peak of our development, we had around 20 or 30 builds per day being tested in multiplayer. And if you multiply that by like 10 or 20 of these resources per build, we had something like 300, 500 resources floating around. And it's kind of awkward walking around saying, hey, could you please shut down your resources? Could you shut down your resources? So we will just auto-scale down these resources and free them up. So that's Fleet Deployer. How does it work? It's a .NET Core application we've written. It sits in EKS. It uses a number of services. But I think the main thing I wanted to call out is that it uses the GameLift API. GameLift API has been super flexible for us. Everything we can do within the console, we can do via the API, so we pretty much never have to log in to the console. Some pages. This is just an example of creating a fleet, just using some drop-downs. You can set a description. You can set like a timeout. Some metrics available in the tool, but we often do just link back to Grafana. And this is an example, but we have like a list of deployments. So while Fleet Deployer is only available within Zynga, hopefully this inspires those that are thinking of using GameLift to understand, OK, well, what do I need to build around GameLift to make it an easier tool to use? So finishing up in terms of pre-launch, in terms of that launch day that you're trying to not stress about, make sure you're using the same workflow from dev through to soft launch to the production. We use Fleet Deployer, but whatever you're using, make sure you're using it from the beginning so you come across any bugs when you do. Set up your dashboards and load test throughout the process. This load testing is going to make sure that your deployment process works, and it's going to make sure that you're displaying what you need on your dashboards. Word of warning, obviously, if you're doing a load test and you're trying to maximize the transactions per second, you can push through a region. Make sure you're not doing that on the same region as your production servers. And then that pre-allocation discussion we talked about, those calculations, do those calculations, get those numbers to Amazon, and scale up your fleets before launch day if you feel that you need to. It's not something you have to do, but as a precaution, we pre-warm our fleets. We make sure that we have enough empty fleets sitting there, so if a new season comes out, a new trailer drops, we're ready for players to be joining the game. Finally, talk to your GameLift partners. They're probably going to give you some advice that you may not have thought about, and they may ask some questions about TPS instance utilization and all of that. So yeah, that's it for me, looking kind of inwardly at, I guess, GameLift itself. And I'm going to hand it off to Chris, who's going to talk more about implementation. Thank you, Chris.
Awesome.
Got it.
I got it. Thank you, Adrian. And as Adrian said, I'm going to talk a little bit about the development process and how we actually use GameLift inside of Unreal and our platform services. The quick disclaimer is this is not going to be thorough, in-depth code discussion or anything. I'm just going to try to do a quick run through to give you an idea of what's needed. The first thing to call out is the integration points for GameLift. We only have to do it in the Unreal game server itself. There's some functions and some callbacks you need to implement. And in our case, we also used our platform services as the central communication point for matchmaking. The game client itself doesn't even know GameLift exists for all intents and purposes. It just knows how to matchmake and get server information back. So for the Unreal server integration, like I said, there's a bunch of functions and callbacks you need to implement. I'm just going to run through the list real quick with a brief blurb. Some of these are optional, some are required. Some we did on Hunters, some we didn't, and I'll just give a quick run through. First up is the init SDK. You got to be able to talk to GameLift. Process ready. This is when the Unreal game server notifies GameLift it's ready to host sessions. So like the boot up time can take a minute. Once it's done, it can send this back saying I'm ready to go. On start game session, this is the callback to actually start a game session. And then activate game session. And this is notifying GameLift that the game session is ready to accept players. Process ending, notifying GameLift that the server is shutting down. And then on process terminate, this is a callback used to notify the Unreal game server of an incoming shutdown. So we use this because we use spot instances, so we need to be able to shut down the game server if it comes in. But it can also be used for health check failures, and that is the next one I was going to talk about. The on-health check is a callback you can implement to notify a GameLift the status of the game server. Make sure everything's still running accordingly, and GameLift can terminate it if something's going wrong. Accept player session and remove player session. This is just checking with GameLift on player sessions. Accept is validating that the player is supposed to be there. Remove is letting GameLift know that the player left for whatever reason. And then one that's optional that we didn't do on Hunters is get compute certificate. So if you want to encrypt your network traffic for whatever reason, you can do that. We do that. We just went a different route on that one, so we never implemented that. The next main touch point is for SNS. So FlexMatch, we send in a matchmaking request. FlexMatch sends back SNS notifications on all the different updates that come through. So on our platform services, we monitor for all these different events. And I'm going to just do a quick run through of all the different events. First one, matchmaking searching, pretty self-explanatory. Matchmaking succeeded, also pretty self-explanatory. And this would contain information about the match and the server information and such. Matchmaking timed out. This can happen if your rules are too strict for whatever reason, or if you can't find a match. The rule set is a set of you can put expansions in there saying, oh, hey, after 30 seconds, I'll accept this. After 60 seconds, I'll accept this. But there is a timeout on there. And so if it goes through all of those without hitting a successful match, you'll get a matchmaking timed out for that ticket. Matchmaking canceled. There is a cancel API, and this is just the notification that that came back successfully. Matchmaking failed. This is like the generic something happened, we don't know what. I think I've seen this 2 times in the last 2 years. It's very rare. Something we don't use on Hunters, but it is possible, is for players to accept a match. And that's what some of these are, the next few ones are about. Potential match created. That's used regardless. It's always admitted. But accept match is if a match was accepted, and accept match completed is everyone accepted and the match is ready to go. So all that being said, our platform services integration ends up looking like this. Up in the top left, we have the matchmaker that Adrian has been talking about with the rule set, the notification target, the queue. All that feeds through SNS to our platform services, and our platform services is the glue that sends that to the client. The client is able to then connect to the Unreal game server once it has a match. What that flow actually looks like is like this. So the first one is once a client boots up, it immediately checks. I realize we haven't talked about this, but you need a latency calculation of some kind to feed into FlexMatch to say what the player's latency is for these various regions. We have some ping servers we set up, and that's the first thing that the client does, is it'll ping those servers to get the latency for all the various regions. The next thing it'll do is get the various currently active matchmaking configs. Arjun was talking, like we have a casual queue, a ranked queue. We might have a special event, whatever it is. It'll fetch those and display those to the player. Player makes their choice, and it starts matchmaking. And that matchmaking request goes to our platform services. Our platform services will add some more data in there, like the rating, what maps we want to use, various other things, and it'll send that into FlexMatch. FlexMatch updates come back down through SNS to platform services. Platform services sends that back down to the client, and then client is then able to connect to a game server. All right, so this next slide is going to be like the big Hunter's architecture diagram. It looks like a lot. I'm going to walk through it bit by bit, just fair warning. So again, we have the game client at the very bottom in the middle there, right? And the first thing it does is it sends off the latency check to our ping servers. It fetches the match configs from the platform service in the middle. It'll start matchmaking. Matchmaking goes up to the right into the FlexMatch. Statuses come through SNS back to the platform services, and it sends those results back down to the game client. The Unreal game server itself, when it's starting a match, it'll also call into platform services to fetch player information, like what they have unlocked, some mode information, some config information, stuff like that. When the match is done, the game server sends that information back to platform services, which will process and give out rewards and whatnot, and send that information down to the client. And then included for completeness, but not necessarily relevant for this, our platform services are backed by Elasticache Redis, just for caching that we do, Aurora Postgres for all the DBs, and then we have some central Zynga game services that we use. So this brings us to the launch successes. I've been a part of a few game launches over the years, and Hunters was probably the smoothest launch I've had the privilege of being a part of. So the various successes we had is like our scaling met the player demand. Arden started the story off with the dreaded, oh, there's not enough capacity, people can't play the game, what do we do? Thankfully, we did not run into that situation during our launch. We had plenty of capacity during our launch week and have had no issues since. During the launch weeks, we were able to leverage the scaling to optimize our costs. We had some estimates that were apparently estimates, and so we were able to tune in, get the costs down to where we wanted to be, get our scaling in and our costs where we wanted them to be. We were able to adjust our matchmaking rules on the fly. We had some issues where we discovered some assumptions we were making were not correct, and we wanted to get our times a little bit better, and so we were able to fiddle through that on the fly, but there's, in general, no real issues there. And then we also had the awesome support from the Amazon GameLift team. Up next, we have some slides about our various launch metrics. So Hunters was in soft launch for a period of time before the launch. Our official launch was on June 4th of this year. And so here you can see the current player session count leading up. You see the soft launch numbers there on the left, just a few bit of players trickling in here and there. And then as we ramped in through launch, our player session counts went through the roof. This next one is very similar. It's only counting the active game sessions. Sorry for the spikes in the graph. It's because we use like 3 different aggregation systems, and it decided to put those in there for the display. But it's the same thing. As we're doing the soft launch and we led up to our launch, our numbers went through the roof in comparison. And then last up for the metrics, we have our FlexMatch notification statuses. This is my favorite slide. So green is searching. So this is every player that attempted to find a match. And again, you can see this going through the roof. Completed is the matches found, and much smaller because we're doing 1 match for every 8 searching that we get in there. And then we also have the canceled in there. And the failed and timed out are so little they don't even show in this graph. So always nice. And some of the key launch features that got us to this place where we had no issues, right, is the multi-region fleets, as Arden was talking about. It's easy to scale out and deploy in all the regions that we wanted to get to, and easy to manage. And because we were in so many regions, we didn't have any issues with capacity. The EC2 spot instances, being able to use those for some of our fleets was also made it so that we could deploy all these fleets, right? It helped optimize our cost to make sure we could have capacity in all the regions we wanted to, and we didn't have to worry about paying the on-demand or calculating all the reserved instanced costs. Amazon CloudWatch metrics. This is the main thing we use for our matchmaking metrics because FlexMatch has a bunch of those built in. That's how we were able to monitor our matchmaking situation and find out that it wasn't going exactly how we wanted. But we also have all the other built-in metrics around GameLift as well. And then the FlexMatch itself is also the key launch thing. Like I've said a few times, the ability to change our matchmaking rules on the fly, and that for even non-engineers to be able to look at the rule set and understand is just incredibly beneficial for us. And although we had all these successes, there was always challenges, and some of these the main one I've talked to a few times already, right? Our matchmaking rules weren't giving us the results we wanted. So the first few weeks we did a bunch of fine-tuning of our matchmaking requirements and make sure that we were getting the results that we wanted. To do this, we had to do a bunch of test cycles on it, and we built an internal tool to help us with that. It's the matchmaking simulator. What it does is it'll start up basically an entire FlexMatch matchmaker config with a test rule set and a queue, and this tool will just feed in tickets. We get that ticket information based on telemetry from our actual production players. So we basically mirror that into our matchmaking simulator and monitor the results. And then we can tune the rules and get them into the response times that we want to. And then all of this is deployed through the fleet deployer tool Ardern was talking about. That gives us the ability to modify our production fleets on the fly. And then, we wouldn't be in this situation with all these successes without the GameLift team support. They were engaged with us throughout the entire game development lifecycle, pretty much, once we made the decision to use GameLift. We had several architecture reviews with them, plenty of meetings of questions and answers, and like, why does it do this? What's going on here? We saw this weird thing. And, they always took the time to answer and help us figure out what was best for hunters and what we should do. And as Ardern was talking, as we were leading up to launch, we did a lot of testing to make sure we had the appropriate quotas and limits in place. And they were able to help us out with that to make sure, we had the right quota set in all the different regions. And as we led up to launch, they were also in our Slack and our war room available for any issues that would arise. Thankfully, we didn't need to page them for anything. So I'm going to end up with a few recommendations if you're considering using GameLift, just some things to think about before you start the work. One of these Ardern already talked about a little bit, and it's the latency considerations for multi-region fleets. Like, what latency is acceptable for your game is basically the question that needs to be answered. We spent a lot of time on this with hunters, and we finally came up with the range that we figured was acceptable, but we are a real-time shooter. If you have a turn-based strategy game that is multiplayer, it might be a little bit different for you, right? What are your matchmaking goals and data requirements? What do you want to matchmake on? What's important for the player experience? And do you have the data available to actually implement that? Because it's one thing to say, oh, hey, we want to matchmake on rating and make sure it's all great, but like, how are you going to calculate that rating? What goes into that? Just some questions to consider. What instance type and game session capacity is available for your game? Ardern also mentioned this. We did a lot of testing for hunters, and we came up with the instance types that we decided were acceptable, and 4 game servers to an instance. It's going to be different for every game, right? We are a relatively small, 4v4 shooter. If you have 60 players in a match, you might, only get 1 per instance. It's just something that takes a little bit of testing and consideration. And then lastly, what points of GameLift integration do you want to take on? We went all in. We used GameLift and FlexMatch. FlexMatch is not required. You could just use GameLift if you wanted. But when you're using GameLift as well, what APIs are you going to use through that optional list? What is required? What isn't? And then also, how are you going to test this in the future? Ardern brought up a load testing as we got to production. We were able to stand up full GameLift fleets and test this out because we made sure that we weren't totally reliant on some of these things. And with that, I'm going to hand it over to Steve.
Thanks, Chris. One requirement that grew out of lessons learned from the launch of Star Wars Hunters was the ability to test in a local GameLift-like environment. That wasn't available to the Hunters team, but now with GameLift Anywhere, they have the ability to set up a local test environment, identify a local workstation as a fleet compute source, and then easily transition to a GameLift managed fleet. Setting up a GameLift managed fleet, or I should say setting up an Anywhere fleet, is as simple as identifying your local workstation as a fleet compute source, registering that workstation, and then that game session can be replicated and used for testing. Once you're ready to transition to a GameLift managed fleet, it's as easy as changing one server call to remove the GameLift Anywhere fleet parameters and start using your GameLift managed fleet with a build that's deployed to that fleet. The GameLift team plans to use GameLift Anywhere for local development and future iterations of the game. To get started with GameLift Anywhere, to get started with GameLift, choose a plugin to install, either Unity or Unreal. The standalone plugins are available and have all the libraries necessary to build your game. For custom game engines built with C++, C#, or Go, SDKs are available to support local game development. To get started, as I mentioned earlier, you can use GameLift Anywhere. And while developing, the GameLift console is available to capture metrics and track sessions and even look at player usage with your test environment. If you'd like to try GameLift first, Workshop is available that guides users through deploying GameLift fleets, building queues, and getting hands-on experience using the service. Leveling up that experience, if you'd like to move directly to using GameLift, you can get started with deploying a fleet, using the plugins, using the SDKs, and the GameLift toolkit there's a GameLift toolkit on GitHub that contains sample game scripts and code examples for solving different issues that might come up with GameLift. The tools also include a fast build update tool for deploying builds to fleets. That's it for us today. Thank you. Please please complete the survey in your reInvent mobile app. We're not going to be doing a formal Q&A, but we'll all be available right now to talk.